So once again, this is chapter 9, so do not be fooled. This is 9-2. All right. Now, measuring angles and arcs. Now, guys, a central angle. Obviously, this whole unit is on circles, okay? So a central angle, guys, is an angle whose vertex is at the center of the circle. I think of it as a traditional slice of pie, okay? That's a good central angle thought. If you had to imagine it, it's a good slice of pie where it goes straight to the middle, all right? So that's your central angle, all right? Now, guys, the sum of central angles, it's like how many degrees are in a circle. That's how many degrees are in your sum of central angles. It's 360. All right. So there's 360 degrees in a circle, which means you have a sum of 360 degrees in your central angle. All your angles added up. Now, if we determine the measure of each central angle, all right. So if we look at slice of pie A, central angle A, it says it's 10% of that circle. So if the entire circle is 360 and central angle A is 10% of that, how would I figure that out? 10% of 360, guys, which is 0.1 times 360, or you can just think it's 36. All right. So this one is going to be 36 degrees.
Like E is 45% of 360?
Yes, and that's even easier, guys. If you think about it, 25% is what's a quarter of 360? 90. So this one is 90. All right. Now, the rest, I want you to find the rest. You're going to have to round. What? 3.6. That was a good job, Logan.
Tough math.
Okay.
I try to find 18%.
0.18. Baby, 0.18 times 360 is not 2,000.
Oh, I did 360.
Yeah. Okay, so for 24%, you could have said 0.24 times 360. I'm sorry. Yeah, 24%, 0.24. You got to make it a decimal.
I thought you could just multiply 3.6 times 24 and get it.
Okay, that's technically no. It will work. It's just not based on the right proper math. Normally you make the percent into a decimal and multiply it. But it's gonna, so it'd be 0.24 times 360, which is going to be 86.4. Now, yeah, I know. Like I said, you did the equivalent. You did the mathematical equivalent and got the right answer, but your thinking on why to do it was flawed, which is what I was trying to address. Baby, you could, but I'm saying it's just not mathematically correct thinking. All right? So then 23%, so that's 0.23 times 360. Or if you know that every percent is 3.6, you could have just subtracted another 3.6. You would have gotten 82.8 degrees. And then finally 18%. Will, it's your time to shine.
64.
Good job. 64.8 degrees. Now, boys and girls, obviously when I add all these up, I should equal 360. If not, something's wrong. All right? Now, so those are central angles. Like I said, I always thought of it as a traditional slice of pie.
We have questions where we don't have, so. No, wait, no.
What was that?
I love our talks. All right. Now, hey, you.
Hey now, you're wrong.
Hey, you. Get it? All right. So, boys and girls, I need everybody to understand this. An arc is a piece of the circle. Okay? It's a circle segment. Now, guys, every central angle separates your circle into two arcs. One of them is going to be a minor arc, and one of them is going to be a major arc. Listen to me carefully. If it has two letters, it is automatically a minor arc. If it has two letters, it is automatically a minor arc. I'm going to say it again because I got a lot of people mess this up on the quiz. If it has two letters, it is automatically a minor arc. Now, guys, so a minor arc is always less than half of the circle. All right? Now, a major arc, guys, has three letters to determine or to show direction. Okay? Listen to me carefully, though. Major arcs, a specific type of, semicircles also have three letters. All right? Semicircles are exactly one half of the circle, 180 degrees, okay? So I'm telling you, if it's two letters, you automatically know if it's a minor arc. If it's three letters that I've named, you need to check to see if it's a semicircle, or if it's not, it's a major arc, okay? Now, once again, okay, so semicircles are exactly half, okay? And they are also going to be three letters. So if it's two letters, it's automatically a minor arc. You don't even have to think about it. You don't even have to look at the picture. Because, spoiler alert, Friday, you're getting a picture. And it's going to have a lot of letters on that circle. I have lists of different arc names, and you have to identify it as a minor, major, or semicircle. Okay? I am telling you now, if it is two letters, you don't even need to look at the picture. You write down minor. If it's three letters, you need to look at the picture and see if it's a semicircle, or if it goes beyond that, it's a major arc. Okay? Now,
Major arc also be on.
If it was a semicircle, why would the direction matter?
because it's telling you which part it's talking about, which part of the circle, which direction you're going to shade.
That second thing is not a semicircle.
Okay, no, this second picture.
Like, if you have
Okay.
three letters inside.
So, for instance, HUY goes from H through U and stops at Y. That is the major arc. Okay? So both of those guys are circle E. All right? And I could have a U on this one if I wanted to. But if I say arc HY, then all I'm going to do is start at H and go to Y, and that is the arc to which I am referring. All right? If I say HUY, that means you start at H, go through U, and stop at Y. Now, please look the assemblage. All right? If you know the assemblage for a line segment is a straight line over it, the assemblage for an arc is a slightly curved segment over it. Okay? It's got a slight curvature to it. Now, guys, your arc measures are going to be equal to the corresponding central angles. All right? So, for instance, this is a central angle, and it's 88 degrees, which means the measure of AB. Now, listen, guys. Please listen, because there are differences when I'm talking about arcs. I can talk about arc length, which has no degrees on that answer. I am literally talking about how long, how big is that arc, okay? Those are answers in like inches, feet, centimeters, okay? When I'm talking about arc measure, though, arc measure is always in degrees, okay? So arc length is going to be talking about, it's going to depend on the bigness of the circle. But I could make a circle 8 times that size And if I make it a similar figure, that arc's still going to be 88 degrees, just in a really big circle. Okay? So when I'm talking about the measure of an arc, all right, just like for the measure of an angle, I have to write a little M in front of it to let you know that I'm not talking about the length of that arc. I'm talking about the degrees, okay? So the measure of arc AB is going to be the exact same as whatever my central angle is. So in this case, it's 88.
Okay, so the measure of the central angle will always be on there?
Okay, so either I am going to give you the arc measure and you have to tell me the central angle, or I will give you the central angle and you have to tell me the arc measure, or I will give you enough information for you to tell me the answer. So for instance, if I asked for the measure of arc ACB, I did not directly tell you that, but you have enough information to give that to me.
That would be,
Well, it would be 360 minus the 88.
Yeah, that's why
You see what I'm saying? So there's going to be enough information for you to get that answer every time. Yes. Okay? Does that make sense? All right. Now, so once again, guys, Bo had an excellent question. There's always going to be enough information, even if it's indirectly there. So for instance, to get that major arc, I would do 360 minus the 88. Okay? Now, a semicircle is an arc whose measure is exactly 180 degrees. Now, definition of arc measures. This is what I was just talking about. The minor arc is always just the central angle. Major arc is always going to be 360 minus that the measure of the minor arc central angle. And then semicircle, you don't have to think about it. It's 180 degrees. Now, guys, here's one thing that I need to make sure. Let me see if it's on the next page. Okay, yeah, it's on the next page. All right. No. All right. Shh, I need you to focus. All right. So, everybody good with arcs measures and how to find them?
Is it still a major arc if it's like 3 letters before semicircle? That's still a major arc.
A semicircle is exactly 180 and major arc is over 180. Okay? Now, adjacent arcs. Guys, they're just like adjacent angles. They're going to share an endpoint. Okay? So, arc addition postulate is the same thing as segment addition postulate and angle addition postulate. You can take 2 small arcs, add them up, get a larger arc. Okay? No big deal. All right, so I've got genes on my circle. All right? So I've got circle E. Measure of angle AEN is 18 degrees. JN is a diameter. And the measure of angle JES is 90 degrees. Go ahead and find each measure that I asked for, please.
Yes, ma'am. You're funny, man. You're funny, man.
Go ahead. Work it out.
Shh.
18 minus 180.
I'm going to draw it too, Will. Number 8. I know 18. Leave it A. Let's use a
18 minus 180 is 160. Jade is 180
Hold on.
minus 18.
It's just fine. A.
I'm telling you the last number.
Okay.
You're like, 160. I'm like,
JAS.
JAS. Now what do you do that? That'd be 162 minus. Or 360 minus. What do you get 90 from, dog?
JES.
Why do you need 90? You don't need 90.
You do need 90. Let's see
Subtract
what.
360
Hey.
minus.
yeah, that's where he got the.
I can make it
360
swear.
minus 62.
No. I think
If
it's
you solve
wrong.
for JA.
I feel like I own.
Oh.
I got gold. Stop.
Yes.
No, look. Stop. Oh, that's pretty good.
Don't talk.
JAS.
I got answers.
For the outside.
I think my answers are wrong. I got like, wait, is that a two?
Okay, I feel like everybody that I'm listening to and spying on has A correct. I feel good about saying that everybody knew that that was 18 degrees. All right. I heard at least 2 groups get B correct. Anybody want to tell me?
162.
All right. So guys, listen, in case you, most of you picked up on that right away. When it tells you JN is or anything is a diameter, that means a semicircle, is automatically present. Okay. So 180 minus that 18 is going to be 162 degrees. All right. Then JES is 90. All right. Which means arc JAS is going to be the whole circle minus the 90. 360 minus 90.
At least
270. Good job. Yeah. No, I heard you. Okay, so that's just one example of how we'll use arc addition postulate. Very simple. Any questions? I feel like most everybody understood that. Okay, guys, please pay attention. Y'all, we are going to use some common sense here. So I need you to pay attention because if y'all, formulas are so hard to remember. Okay, you stop. Sit down. Sit down. Wait. Guys, formulas are really hard to pay attention to or to memorize unless it makes sense to you. Okay? Now, guys, I already said it doesn't matter how big or small my circles are. All circles are similar, which means my angle degrees, if my central angles were corresponding, that means if this circle was just really tiny and its central angle was 88 and this circle was extremely huge, but their angles corresponded, that one would be 88. So does everybody get how central angles do not depend on the size of the circle at all?
Yes.
Okay. No matter what, the central angle is always out of 360. Okay? So to get the arc length, it is always going to be central angle out of the 360. Now, guys, so central angle out of 360, that central angle is just going to tell me how much of the circles I'm taking up. Like if my central angle is 90 degrees, I know I'm taking up a quarter of the circle, right? I still don't know how big the circle is though. But that's why we need that part to tell me how much of that arc length we're talking about. Okay? How much of the circle we're talking about. Now, this is what I do need though. I need to know how far around the circle is anyway. I need to know the circumference. All right? So, arc length is always going to directly relate to how big the circle is, pi times diameter. Okay? So you're going to set up a proportion every time and cross multiply. All right? So, guys, it says in circle P, PR is 9. So we're going to draw. I'm going to draw circle P. So here's circle P. All right. It tells me PR. All right. So this is P. This is R. And I'm going to label it 9. Now, all right. Then it says the measure of angle QPR. So now I need to add a Q somewhere. So I'm going to add a Q right around here. It doesn't really matter. And I'm going to go ahead and label this. Oh, Lord, I'm going to have to cheat because I cannot draw a line. I know that angle is 120. All right. Now, go ahead and figure out the length of that arc, QR. All right. So fill in what you know. Fill in what you know and solve for x. When you think you have it, I can help you out and check. That's the arc length. That's what you're looking for. Your unknown is the arc length in this problem. So you put the x there.
Diameter is gonna be 180, right?
That makes sense.
No, Meg. Diameter is gonna be 18. 1 times 2 is 60. L, Meg. When did he even do it?
You double the radius, babe.
Oh, yeah. Sorry. 9 plus 9. Yes, got that.
Oh, oops. I forgot how to do math.
All right. When you think you know, you can raise your hand. I'll come around and check.
Finally.
Good job for that.
Is it one?
That's the measure. I want length.
So what do you mean?
This is exactly why people fail this quiz. The measure of QR,
Oh, we got to set the proportion.
right, the measure of QR is 120. I want the length of QR.
Hold up. 18.
How do you put pi in calculus?
Second, and then that's
21, right?
How do you get 21?
Good job.
I don't know.
56.5.
Good job.
Because you plug it into the formula.
Anybody think they have it? Yes. Good job.
Okay. I got
Yeah,
it.
we have diameter is 18. I don't think you're from this.
You can round to the hundredth.
Do you want to use my calculator? You might want to get a calculator. Oh, I got it.
Oh, wait. 120.
No, you don't. Wait, what do you do? You don't write it around there. Like, it's like that.
Like you sit on the Hey.
What's up,
Yes, that's right.
That's what I said.
Oh, and we got it right.
Apply that by.
Oh, we're slow.
And then you divide that by.
Go,
Why do you have 3 seconds?
Good job. Okay, I'm feeling like we're catching on, guys. One of the big things, once again, I'm really trying to prep you for this quiz. It's your last quiz of the 9 weeks, and I'm trying to tell you where people mess up. They'll look at this problem and they'll just write down 120 degrees and go on about their life, and I'm sitting there going, why? Why did you do that? Okay, so, good job. So I think I checked with most everybody, but we'll work it out just in case. So all you're going to do is fill in the blanks. Central angle was 120. So 120 over 360. All right. Equals arc length is what we're looking for. So that's automatically your variable. And then if the radius is 9, you double it to get the diameter. So you get 18 pi. All right. And just so you know, guys, when you're doing this, if you wanted to do it in your head, just so you know, 120 over 360, guys, that's 1/3.
It is?
Oh, that's at least.
1/3.
That's at least 1/2.
1 times 18 pi is 18 pi. Divide by 3. You get y'all, what's 18 divided by 3? 6. So the answer is going to be 6 pi if I asked you exact. Okay? But guess what 6 pi is? 18.84, blah, blah, blah. I told you to round 18.85. Okay? So I just wanted to show you that you could possibly do that in your head or get an exact answer. But when you cross multiply, you would get X. Most of you did it that way and got X. Wow, that is a terrible about sign. That's betterish. So 18.85. Okay? Now, So, boys and girls, when you see the term concentric circles, I need you to think bullseye like a dartboard or throwing a rock in a pond in the ripples, okay? It's concentric means one within the other, with all the same center. Con means with, center, with the same center, okay? So like I said, as a kid, I automatically thought dartboard, that's concentric circles, all right? Similar circles are all circles. Guys, all circles are similar.
Okay.
Wait, can you explain the one with the other?
Okay, like a dartboard? Yes, you know how dartboard is
Yeah.
like, okay, they all go to that same bullseye. They're all the same distance from that bullseye.
One within the other,
Yep.
with the same center?
Yep. Okay, guys, congruent circles. Hey, chatty people. Congruent circles, guys. All circles are similar. Obviously, not all circles are congruent. Congruent circles have to have the same radius or diameter. And then congruent arcs. Guys, you're going to have this a lot. Congruent arcs are automatically have the same measure and the same length. Okay? You cannot be congruent if you don't have the same arc length as well. It has to have the measure and the length. Okay? All right, so that's the lesson. All right, so we're going to practice doing these just to make sure we have it. All right. Yo. All right. So you guys are going to work on page 656, 657, 1 through 23.
Choose one. Yeah.
And I'm going to go ahead and tell you. I'm going to go ahead and tell you I need you to listen to me. I have it. I'm trying to get you to listen to me. All right? Yeah, obviously.